This video is brought to you by Academy of Higher Learning. Hello and welcome to today's physics video on kinematic motion. In this video I'll be doing problems. The problems that I'll be doing will be in one dimension, and you need to watch the previous videos or need to have knowledge of kinematic equations, the relationships between graphs, and the basic concepts of displacement, distance, and velocity and acceleration. So let's start. The first question. An object A is moving at a velocity of 5 meters per second. What is the displacement covered by the object in 5 seconds? So first let's start with the coordinate system. Right now it's not very helpful because it's in one dimension. You don't really need it. But later on when you're doing 2D or 3D, it's very helpful. So let's just say right is positive, left is negative. And we have object A, and it has a velocity of VA equals 5 meters per second to the right. What's the displacement? So this displacement would be one of the basic equations. Delta D equals V1T. So basically similar to distance times speed times time. So but in this case it's displacement and velocity. So all you have to do is sub the values in, numbers in. So it'll be 5 meters per second times 5 seconds, and we're left with 25 meters to the right. And if we check the units, it also makes sense. This is meters per second times second, and that would be left with meters. So that's A. And for question B asks us if there was another object B, and I've drawn here, traveling at a velocity of 10 meters per second and an acceleration of 3 meters per second to the right, which object has a greater velocity after 5 seconds? So basically the velocity is negative since it's going to the left, and so VB and VA, so AB, sorry, acceleration of B, 3 meters per second. So let's just find the acceleration, the velocity of A first after 5 seconds. So we need to use another equation. You've probably seen that before. So V2A equals V1A plus AAT. So put the arrows on and basically sub the values in. But since there's no acceleration, V1A equals V2A, so that will be 5 meters per second. So it's a constant velocity to the right. As for the second one, object B, we have V2B equals V1B plus ABT. And basically the initial velocity is minus 6, and the acceleration is 3 meters per second, and it's positive since it's right, and the time is 5 seconds. And we're left with minus 6 equals plus 15. Oh wait, sorry, it's minus 10. So once again, it's minus 10. That's the velocity of V1B, the initial velocity, and it will be minus 10 plus 5, and we're left with 5 meters per second to the right. Therefore, both objects have the same velocity. Same velocity. Again, it's very simple. It's just subbing in values and using the right equation. Second question. A ball is moving at a velocity of 6 meters per second to the left and has an acceleration of 2 meters per second squared to the right. And we have a coordinate system once again. Right is positive, left is negative, and I've drawn the diagram here. Make sure you draw the diagram. It's very helpful and it gives a good visual idea. So question A asks us that what is the displacement after 10 seconds? Now to find the displacement, you have to use this equation. So plus 1/2 AT squared, and all you have to do is sub in the values after that. So velocity is minus 6, and the time is 10 seconds, plus 1/2 acceleration is 2 meters per second to the right, therefore it's positive, and 10 again squared. So we're left with minus 60 plus 100, meaning it equals 40 meters to the right. For the second question, when does the ball start moving in the opposite direction? The ball basically starts moving in the opposite direction when the velocity v2 becomes positive, and for it to become positive, it has to pass v has to pass v2 equals 0 at some point. So this is like a turning point for the velocity, and basically um, and so we just have to solve for that when it becomes v2 0. So we use this equation this time. It's up in the we used it in the previous question as well. And v2 equals 0. We know the velocity is minus 6 plus 2t, and we just have to solve for t. So basic algebra here, 2t, and we find time equals 3 seconds. Therefore, switches direction, okay, after 3 seconds. Last question. See, what is the velocity after 10 seconds? So we use the same equation here, but this time we know v2, but we don't know t. Oh, I'm sorry. This time we know t, but we don't know v2. So we need to find that. Equals v1 plus at, and initial velocity once again is minus 6 plus 2 times 10, and we're left at minus 6 plus 14 and minus 20, because the answer is 14 meters per second to the right. So simple. If you have any questions about this, feel free to leave it in the comments below. The last question is basically you need to understand the wording of the question, but overall it is pretty simple. Basically saying that a car is moving at 40 meters per second. The police car starts chasing it after the car passes it at a equals 2 meters per second. So I've drawn a coordinate system, diagrams, and labeled their acceleration and speed. So let's just say that the cop car at P1 was at just standing there until car A passed it. So let's say that point as x equals 0 meters. But before answering any questions, let's just write down a few equations. So for the police car and for the car A. For the police car, we have the displacement equation, which is v1t. We have to write the displacement and final velocity equations, plus 1 half at squared. So there's no initial velocity, therefore we're left with 1 half 2t squared, and that is just t squared. And the second equation is the final velocity, which is v1t plus at, and once again no initial velocity, therefore it's just 2t. As for the car, same thing. Make sure you put the arrowheads into vector, and the final velocity of the car stays the same because it's not accelerating, so it's just v1, which is 40. Let's just label the equations. So this is equation 1, 2, 3, and 4. So now, since we've done that, let's go and solve some questions. So part A asks us, when is a police car right beside the speeding car? And they're beside each other. So say let's pick an arbitrary point, P2. That's when they're beside each other. And if you find the displacement, both of them have start off at P1, the initial position. So P2, the displacement would be P2 minus P1, and that's just 0. That's just P2. So basically, we just need to find when they meet here. And the way we can find that is by just subbing equation 1 into equation 2. So sub 1 into 2, and basically we get t squared, equation 1, equals 40t. Bring the 40t to the other side, and then solve for t, which will be t minus 40, 0, and t equals 0, and t also equals 40. And this makes t equals 0 also makes sense because initially they were at they did meet at point 1, 1, and that's when the cop car was just standing there while the speeding car just passed it. And the second time they meet, which is P2, is 40 meters. And you can put right, forgot to put that. So this is the answer we are interested in. The second question asks us, do they have the same velocity? And the answer to that question is uh, no. The cop car started from 0, meaning that for a while car A, when it was like when the cop car's velocity was between 0 and 40, the car A was moving away from it. So therefore, like in order for the cop car to make up for the distance that the car A was ahead of, it needed to speed up. It had to be going faster for it to catch up. Therefore, when they meet, the cop car is going actually faster. That's a greater velocity. So the answer is no. And the second answer is, the second question is, when do they have the same velocity? All we have to do is sub in equation 3 and 4 together. So sub 3 and 4, and we get 2t on one side, and on the other side we have 40, and t equals 20 seconds. And to further elaborate on the question B, they have the same velocity at 20 seconds. So how about we just sub that in to the displacement equation and find out what was the distance when they meet. Oh wait, this is seconds, not meters. So they meet after 40 seconds. Sorry. And so basically, once again, you sub the time 20 seconds in the displacement equation and find the difference. So let's just do that quickly. So for the delta dp, which is police, equals, the equation is t squared. And yeah, it's t squared, just want to make sure. And basically the time is 20, so 20 squared, you're left at 400 meters. As for the delta dc, the speeding car, the displacement formula is t for dt. Just sub in the time and we get 800 meters. Therefore, when they have the same velocity, the speeding car is 400 meters ahead of the cop car. So they don't have the same displacement. Or they're not beside each other either. So that's the end of the video. These are basic problems, simple, and all you have to do is sub them in, and you just need to use the right equation. In the next video, I'll be doing two-dimensional examples. So yeah, thank you for watching the video. This video is brought to you by Academy of Higher Learning. You can feel free to subscribe and like us, or leave comments with questions in the comment box below, and visit our website at www.aohl.info. And have a good day. Bye.